In this next part, we will be solving trigonometric equations. A trigonometric equation is just an equation where either the left-hand side or the right-hand side or both of them contain trigonometric functions. Some of them will be very straightforward, others will need a little more calculation. So we'll start off with some basic examples. First one, assume that sine of theta is equal to 1/2. What are the values of theta? The easiest way to solve such a simple problem is to look at the trigonometric circle. If sine of theta is 1/2, this means that the y-coordinate of the point corresponding to the angle theta is 1/2, which tells us that theta is either pi over 6 or 5 pi over 6. However, those are not the only solutions. Due to the periodicity of sine, which has a period of 2 pi, we know that we can add a multiple of 2 pi and still obtain the same angle. So it's not just pi over 6, but it's pi over 6 plus 2k pi. So any full rotation along the circle is also the same angle, or 5 pi plus 2k pi. If, however, the original problem was sine theta is 1/2, and you were given that theta was in between 0 and 2 pi, then you had a restriction. So if you have a restriction, you have to take the restriction into account, and you can only answer with the angles in the domain. So it would mean that the solution for the yellow problem is theta equal to pi over 6, or theta is equal to 5 pi over 6. Finally, it's good to remark that if we had found pi over 6 as a solution, 5 pi over 6 would have followed immediately because of the formula sine of theta is the sine of pi minus theta. For the second problem, you know that the tangent squared of theta minus 3 is equal to 0. What is the value of theta that solves this equation? So this means that the tangent of theta squared is equal to 3, or tangent of theta is the square root of 3, or tangent of theta is minus the square root of 3. For the tangent, it doesn't really make sense to draw the trigonometric circle. What you can do, for example, is plot the graph of the tangent and look if you can find a solution that way. Another option would be to grab back to the table with the special angles and look up the values there. You then see that there is only one solution per period. So if we take the value pi over 3 on the y-axis, this will give us the value for theta on the x-axis. So theta, for the first part, will be equal to pi over 3 plus, as is clear from the image, k times pi, because pi is the period of tangent. Similarly, for tangent theta equal to minus square root of 3, we find that theta is minus pi over 3 plus k times pi. For the third example, take 2 times cosine squared of theta minus 7 times the cosine of theta plus 3 equal to 0. Again, try to find theta. To do this, we will first solve the quadratic equation. So we set cosine of theta equal to t, so we get 2t squared minus 7t plus 3 equal to 0. We calculate the discriminant, so the discriminant, if you calculate it, will be 25. And then we look at the solutions for t. So t will be 7 plus or minus 5 divided by 4, which is 3 or 1/2. Hence, cosine of theta is equal to 3, or cosine of theta is equal to 1/2. Of course, cosine theta equal to 3 is impossible because a cosine is always limited between minus 1 and 1. And cosine theta equal to 1/2 means that theta is either pi over 3 plus 2k pi, or theta is minus pi over 3 plus 2k pi. Again here, notice the relationship. We know that the cosine of theta is the cosine of minus theta, and so if we have pi over 3, we immediately also have minus pi over 3. So far we have been solving the equations quite intuitively, but we will now see a more general way of solving equations. For the first case, assume that sine of theta is equal to sine of alpha, where sine of alpha is known. For example, sine of theta is 1/2. In the case of sine, we will assume that alpha is in the first quadrant or alpha is in the fourth quadrant. So basically this means alpha is an angle between minus pi over 2 and pi over 2. Why? Because in the case of alpha in quadrant 1 or 4, this covers all the possible sign values. As you can see on the circle, if alpha goes from minus pi over 2, where the sign is minus 1, up to pi over 2, where the sign is 1, we have covered every single outcome for sine alpha. So within quadrants 1 and 4, there is a single solution for the equation, namely theta is equal to alpha. Furthermore, because of the formula that sine pi minus alpha is equal to alpha, another solution is pi minus alpha. And then due to the periodicity, we can always add 2 pi. So it's alpha plus 2 pi, 3 pi minus alpha, and so on. If we then take a look at the formula, we see that we have in each step an addition of pi, and that the sign of alpha changes, so plus minus plus minus plus minus. If we want to write it in general, we can write that theta is k times pi plus minus 1 to the power of k times alpha. And this formula is then the general solution to the equation sine theta equal to sine alpha. For equations of the type cosecant theta equal to cosecant alpha, we get the same solution because a cosecant of an angle, so let's say theta, is just 1 divided by sine of theta. And so we have the same problem. For the second type, assume that cosine of theta is equal to cosine of alpha. In this case, we will assume that alpha is either in the first quadrant or alpha is in the second quadrant. So alpha is between 0 and pi. The same reasoning, if alpha is between 0 and pi, this covers all the possible values for the cosine because those are red on the x-axis. The solution is then again theta equal to alpha, or because of the formula cosine of alpha is cosine minus alpha, also equal to minus alpha. And then again we add 2 pi, we add 4 pi, and so on. So we get alpha plus 2 pi minus alpha plus 2 pi, and this continues. And thus the general solution is theta is equal to 2k pi plus or minus alpha. And then because a secant is 1 divided by cosine, this solution also holds for equations secant theta equal to secant of alpha. The third type of formula is then trivially tangent theta equal to tangent alpha. Here again we will take alpha in the first or in the fourth quadrant. So alpha is between minus pi over 2 and pi over 2. And the solution then becomes theta equal to alpha, pi plus alpha, 2 pi plus alpha, and so on. Hence, the general solution theta is equal to alpha plus k pi. Finally, let's see how to solve equations of the form a times cosine theta plus b times sine of theta equals to c, under the condition that the absolute value of c is not larger than the square root of a squared plus b squared. Divide then the entire equation by the root of a squared plus b squared. So the equation becomes a divided by root a squared plus b squared times cosine of theta plus b divided by the same root a squared plus b squared times the sine of theta equals to c divided by that same root. We see then that this coefficient and this coefficient in absolute value is smaller than 1. So it is possible to find alpha such that the cosine of alpha is equal to a divided by the root a squared plus b squared, and the sine of alpha is equal to b divided by a squared plus b squared. Visually, this becomes clear if you take a right-angled triangle with one side equal to a and the other side equal to b. In that case, the hypotenuse here is the square root of a squared plus b squared, and alpha corresponds to this angle. Then plug in cosine alpha, sine alpha, then the equation becomes cosine alpha times cosine theta plus sine alpha times sine theta is equal to c divided by the square root of a squared plus b squared. The left-hand side then simplifies to cosine theta minus alpha. Because of the restriction we set at the beginning, this is an absolute value smaller or equal than 1. And so there exists some angle beta such that c divided by the square root is equal to the cosine of beta. We are now in the second case. So cosine theta minus alpha is cosine beta, which means that the general solution for this equation is theta minus alpha is 2k pi plus or minus beta, or theta is 2k pi plus alpha plus or minus beta. Let us now take a look at some examples. So we have seen the general solutions of the equations, but you are not always confronted with the equations in that form. So assume for the first example that you have the tangent of x times the tangent of 4x equal to 1. So we see this is not immediately the same form, so we have to rework this equation to put it in one of the 4 cases we saw. So what we will be doing is saying tangent of x is 1 divided by the tangent of 4x. So this is the cotangent of 4x. And then we know that the cotangent of 4x is the same as the tangent of pi over 2 minus 4x. And now we are in the case tangent theta equal to tangent alpha. The general solution is then x is equal to pi over 2 minus 4x plus k times pi. Or 5x is pi over 2 plus k times pi, or x is pi divided by 10 plus k times pi divided by 5. One small remark with this type of exercise: if you have to solve such an exercise on the exam, you are free to choose the way that you solve it. So either you do it on site or you use any of the equations or the cases. It's all good as long as you get to the correct solution. To solve certain equations, you will also need to use the identities that we saw before. Take, for example, the following example. 1 plus sine of theta is equal to 2 times cosine squared of theta. The easiest way is to try to set everything back in sines or cosines. So what we here will be using is that the cosine squared of theta is 1 minus sine squared of theta. Therefore, this equation becomes 1 plus sine theta equal to 2 minus 2 times sine squared of theta, or 2 sine squared of theta plus sine theta minus 1 is 0. We will first again solve the quadratic equation, so set sine of theta equal to t. Then you get 2t squared plus t minus 1 is 0. Solving this gives you a discriminant equal to 9, or a solution t is minus 1 plus or minus 3 divided by 4. So t is either 1/2 or minus 1. This thus means that sine of theta is either equal to 1/2 or sine of theta is equal to minus 1. Sine of theta is 1/2 if the angle is pi over 6, and so the general solution for the first part becomes k times pi plus minus 1 to the power k times pi over 6, and sine of theta is minus 1 for minus pi over 2. So here we get k times pi plus minus 1 to the power k times minus pi over 2. Try to solve the following questions on your own. Sine of 2 theta minus cosine of theta equal to 0. Tangent of x minus cotangent of x equal to the cosecant of x. Sine x plus 2 cosine x equal to 1. Cosine of theta plus 1 equal to sine of theta, but under the condition that theta lies between 0 and 2 pi. And finally, cosine theta plus cosine 2 theta plus cosine 3 theta equal to 0. So try to solve these on your own to see if you grasp the concept of the equation solving before looking at the answers on the following slides. The first step here is to change sine of 2 theta by 2 times sine of theta times cosine of theta. Then you get this minus cosine theta is 0. Or 2 times sine theta minus 1 times cosine theta is 0. This means that either 2 sine theta minus 1 is 0, or the cosine of theta is 0, or sine of theta is 1/2, or cosine of theta is 0. Sine of theta equal to 1/2 corresponds to pi over 6, so we get theta is k times pi plus minus 1 to the power k times pi over 6. Cosine theta equal to 0 equals to pi over 2, so here we get pi over 2 plus k pi. So here we are stuck with a tangent, a cotangent and a cosecant. So the first thing that we will have to do is to simplify the equation. The easiest way is just to write out all the formulas. So tangent is sine x divided by cosine of x minus cosine x divided by sine x equal to 1 divided by sine x. So putting everything on the same denominator on the left hand side, you get sine squared of x minus cosine squared of x divided by cosine x sine x equal to 1 divided by sine x, or sine squared of x minus cosine squared of x equal to cosine of x. We are now stuck with sine squared, cosine squared and cosine, so what we will be doing is change sine squared into something in cosine, which is easy to do because we know that sine squared plus cosine squared is 1. And so we get in the end here 1 minus 2 cosine squared x equal to cosine of x, or 2 cosine squared x plus cosine x minus 1 is 0. Solving the quadratic equation tells us that cosine of x is equal to minus 1 plus or minus the square root of 9 divided by 4, so it is minus 1 or 1/2. Cosine x is minus 1. We have minus 1 if we have pi, so cosine x minus 1 means that x is 2k pi plus or minus pi. But we can simplify this equation because plus or minus pi is the same thing. So this is basically 2k pi plus pi, or it is 2k plus 1 times pi. If cosine x is 1/2, then we know we have pi over 3. So it is x equal to 2k pi plus or minus pi over 3. Or if you want to rewrite it, it is 2k plus or minus 1/3 times pi. In this problem, we are confronted with something of the type a times cosine theta plus b times sine theta. So here what we see, a is equal to 2, b is equal to 1, and we will be dividing by the square root of a squared plus b squared, so the square root of 5. Hence, we get 1 over square root of 5 times sine x plus 2 over square root of 5 times the cosine of x equal to 1 over square root of 5. So we need to find the angle theta such that sine of theta is 1 over the square root of 5 and the cosine of theta is 2 divided by the square root of 5. The angle will be found by looking at the triangle, so the right angle triangle. Sine of theta has to be 1 divided by the square root of 5. So if we call this angle theta, we know that the opposite side has to be 1 and the hypotenuse has to be 5. Cosine of theta has to be 2 over square root of 5. So we get here 2 and hypotenuse is square root of 5. So we see that the tangent of theta is 1/2, or theta is tangent minus 1 of 1/2. And so the left hand side of the equation then becomes cosine of x minus theta. And this has to be equal to 1 over square root of 5. And this one, for 1 over square root of 5, we have to equate this also to some cosine. If we look in the same triangle, then if we take this angle here, and we call it alpha, then you see that the cosine of alpha is the adjacent. So it's 1 divided by the hypotenuse square root of 5. So cosine of alpha is 1 over square root of 5 in this case. And if we then look at the angles, we see that alpha is nothing else as pi over 2 minus theta. And so the right hand side becomes the cosine of pi over 2 minus theta. So this means that x minus theta is 2k pi plus or minus pi over 2 minus theta. So this 2k pi plus pi over 2 minus theta, or 2k pi minus pi over 2 plus theta. And thus x becomes equal to 2k pi plus pi over 2, or x is 2k pi minus pi over 2 plus 2 theta. One way to solve this equation is to square both the left hand and the right hand side. So this gives me cosine theta plus 1 squared equal to sine squared of theta, or cosine squared plus 2 cosine theta plus 1 is sine squared of theta. However, beware, because of taking the square, we lost the information of the sign, so we get in the end more solutions than we are allowed to. So we will have too many solutions in the end, and so you will have to check what solution is a true solution and which one is not. We then replace the sine squared by 1 minus cosine squared, so this is 2 cosine theta plus 1 equal to 1 minus cosine squared of theta. We bring everything to the same side. 2 cosine squared of theta plus 2 cosine of theta is 0, or 2 times cosine theta times 1 plus cosine of theta is 0. So it means that either cosine of theta is 0 or cosine of theta is minus 1. Because our solution space is limited, we find the following solutions. Cosine theta equals to 0 means that the theta is either pi over 2 or theta is 3 pi over 2. Cosine of theta is minus 1 means that cosine of theta is pi. And then we have to check these solutions. So we have to check if the solutions that we found at the end are also solutions of the initial equation. So check the solutions one by plugging them into the equation. If theta is pi over 2, then cosine of theta is 0 plus 1, and the sine of pi over 2 is 1, so this is okay. If theta is 3 pi over 2, cosine is 0 plus 1, but the sine is minus 1, this is not okay. If theta is pi, then we get the cosine of theta is minus 1 plus 1 equal to the sine of theta is 0, so this one is okay. So in the end, what we see, we have two solutions. Theta is pi over 2 and theta is pi. And the solution 3 pi over 2 is not a valid solution because the left-hand side has a positive sign, the right-hand side has a negative sign. For the final one, we have a sum of 3 cosines. One's cosine theta, one's cosine 2 theta, one's cosine 3 theta. So these are not simple to work with, and what we will be doing is we will group them together in such a way that we can simplify the equation. For this, we will be using sum to product formulas. And we will apply this to cosine 3 theta and cosine theta. This then gives cosine 2 theta plus 2 times cosine 2 theta times cosine minus theta equal to 0. Or cosine of 2 theta times 1 plus 2 times cosine theta is 0. So cosine of 2 theta is 0, or cosine of theta is minus 1/2. And thus 2 theta is 2k pi plus or minus pi divided by 2, or theta is k pi plus or minus pi divided by 4. If cosine of theta is minus 1/2, this means that theta is 2k pi plus or minus 2 pi divided by 3.